right. Good morning, good afternoon, good evening, wherever you are. If somebody wants to just give me a sound check, that'd be great. I had some issues here this morning with one of the systems I wanted to use for the presentation, and I just switched to something else. So I believe the audio should be good. Let me just double check on my side here. Yep, it seems okay. All right, so what we're going to cover today is essentially the changes that were made in Android 15 for the HALs. You're going to see that there's some interesting stuff that's happened there that is worth taking a closer look at, because I think it will have impact on, and thank you, Stefan, for confirming the audio. Yeah, so essentially there's some interesting stuff that you're going to have to take into account moving forward in the way you actually work with the HALs. So the slides that I'm presenting I will share a bit later on, so bear with me here as I make those available, but essentially, you know, let's just go through them here, and as soon as I get the chance, I'll make them public. Anyhow, whatever, you can look me up. I've written 2 books for O'Reilly, one on embedded Linux, one on embedded Android. Wrote the Linux Trace Toolkit, which was one of the first tracing tools for Linux. Fortunately, a lot of other people are doing a fine job at maintaining tracing tools in Linux these days, and I'm very happy not to take care of that. And without further ado, let's actually get into the meat of the topic. So, what I want to cover with you today here is to look at what initially looks like a very sort of organic, normal, run-of-the-mill release with no really interesting things. But then if you take a closer look, it's like, wait, what's going on here, right? And so in order to fully grasp what's going on, I thought that one of the interesting things to do would be just take a step back and see the history of the HALs. How did we get here? What were we trying to accomplish? And what does 15 initially exhibit in terms of changes, and then what can we find out as we go through a bit deeper. Another thing that I'd like to do a bit, and we'll see how the time goes, is to give you a bit of a code walkthrough of how to actually write HALs using AIDL. A couple of years back, I had done a live stream comparing how HALs were done in the old style sort of library model, and then how we evolved into the HAL HALs stuff afterwards with the introduction of treble. And the AIDL stuff is not new by any means. It's been there since about 11. It's just that I've sort of never bothered to actually just sit down and actually do a walkthrough of that over live stream, and I think maybe this is a good opportunity since I'm already also covering the other thing that's happening to HALs, and seems to be happening in HALs in 15, which is the apexation or apexization, or whatever it is, however you want to verb this, or pronounce it. So in other words, the conversion of HALs into Apex files. And so the AIDL stuff is also intrinsic to that, because we were now using AIDL across the board. So might as well just cover the whole thing together. All right? So this is what was announced in Android 15, all right? Mainly when a new release comes out, I usually go to the source.android.com website, and I'm interested there in looking at the actual architecture section of the explanation. So essentially here, if you go to the, so this is essentially under source.android.com. There's release notes. You can see there's release notes from a whole bunch of versions. The one, there we go. So the one from Android 15 essentially doesn't really kind of announce a lot of stuff, not to undermine the work of anybody that's worked on these things at all, but just saying essentially here, the one that sort of caught my eye was this here, this deprecation of VNDK. And the first time I saw this, I was like, what are you saying? Because I thought the VNDK was kind of important, since you wanted to make sure that your HALs, at least among other things, would continue working across versions. So if you're deprecating VNDK, what are you replacing it with? And on that topic, it's mum. It doesn't actually tell us what it's doing. And it took me quite a bit of time to figure out what does that actually mean, and what does this sort of entail in terms of how we build stuff, and so on and so forth. All right. So, sorry, switching to the wrong window here. So yeah, the other thing, which is the 16K kilobyte pages, very interesting stuff, by the way. There's been a couple of talks about that at Linux Plumbers. Go take a look at that. But anyway, so let's go take a look here at the overall history of HALs and how we got here. And for those of you who've been working on this day in, day out for years, maybe this is going to sound pedantic, but I'm also seeing a new flock of people sort of coming into the world of AOSP, and we can see that, so by the way, those of you not familiar with the aospdevs.org should check it out. This is a new sort of community effort of trying to create a rallying point for those working on the platform side of things that is not necessarily sort of hooked onto Google. So this is, you know, the fruit of some discussions at the last Linux Plumbers, following some presentations on the topic, namely by Chris Simmons. We founded this site to help people sort of find resources. So anyway, have a look at that, and you know, by joining into this, I'm seeing a lot of new people, new sort of fresh blood, if you will, join in the efforts of working on the platform. And as such, let's assume that some people may not be as familiar or have been around long enough Android to sort of understand the actual issues that we are trying to solve with this hardware support and so on. So this is going to sound really basic, but the initial question that has to be asked is, we have an app ecosystem and we need to give it access to hardware. How do we do that? And we have a system that has to manage hardware, and how do we actually do that in the context, of course, of an operating system that's going to be used by billions of people on the planet at the same time, with a lot of variance. So the first thing that we sort of want is to make sure applications don't actually get access to hardware, at least not directly. So we sandbox the applications. That's one thing that Android does, has been doing for forever. All right. So essentially, the applications cannot just open hardware and read and write to it. You can't open dev foobar and start making access to whatever that is. Not possible. All right. So simple solution. Let's put some system in between and give it an API to applications. All right. So that sort of solves that initial problem. But then the question is, how does the actual system talk to the hardware, especially since it's not hardware 1, but hardware N. There are many hardware devices out there running the same version of Android. So how are we going to actually provide the ability to talk to all those things in the same time? And that is how the HAL is born in the world of Android. So essentially, the system inside of Android is architecture such as Google provides two things: system services, which are sort of the main purveyors of the API that applications use. I'm simplifying a bit for those of you who know what I'm talking about. And then essentially you got the HAL specification, which Google provides, and then the manufacturers, however you want to call them, they provide an implementation, and this actually talks to the manufacturer's hardware. All right? Simple enough. At least that is the overall architecture. And by the way, regardless of treble or non-treble or AIDL or HALs or whatever it is that you want, that really is the architecture we've been following with Android for the past 20 years. So it really hasn't changed in that regard, or almost 20 years since the date of release. So this has been constantly true. Now, prior to treble, what did this look like in terms of the bits and pieces? All right, I'll show you some code a bit later on, but let's just keep it simple for now. So we essentially have here the system server process, or one of the system server processes, maybe. So the system server process main, which has all the Java ones, will look a bit like this anyway. For all the other ones which are native, they'll start somewhere else, and they may not have all these layers. But anyway, simplifying things again. So we have an AIDL file. For those of you not familiar with that, it's a interface definition language. It just says, here are some calls. It looks like a bunch of C function prototypes in a header file. All right. So we specify this there, or Java interfaces for those of you familiar with that. So this is used to write some Java code, which used to usually have some C++ code, which would then interface with some HAL definitions to talk to a HAL implementation file, which, by the way, was an SO file. This would then use the system libraries to actually access whatever it needs. And there was a service manager, single one, for the actual sort of retrieval and advertising of system services that are there. Now, two drawbacks with this schema. The HAL definitions are headers, C++ headers or whatever. And the problem with that, of course, is that from version A to version B or version X to X+1, whatever you want to call them, those would change. And if you change those, well, problemo. Your SO file is no longer good. You have to rework that to make it valid. And so that's a sort of a forward maintainability issue. And then the SO file is problematic because if it crashes, well, bye-bye system server, all right? So that is definitely something that has been those two things have been issues for motivation, so to speak, to get the treble stuff going. So what changed with treble, version 8, by the way? So essentially we replaced the header files with HAIDL definitions. I very much like HAIDL. It's gone to 6 foot under now, but anyway. So one of the interesting things about HAIDL is essentially it could allow you to either go to an SO file or a remote implementation sort of more or less transparently, so long as you told the system which way you were going using a manifest file to specify the actual conduit that was going to be used, transport as they called it, the real term. They also introduced two new managers, Hardware Service Manager and VND Service Manager, and in all cases, so that your hardware would outlive the version of Android that you were using, they provided something new called the VNDK libraries. All right, so essentially here you've got a bunch of libraries that were supposed to, continuously show the same API or work the same way, so that the modules that you wrote using HAIDL would work exactly the same as before. All right, with Android 11, they introduced the use of AIDL for hardware interfacing. And in that case, essentially, instead of the definition being in a HAIDL file, essentially it's an AIDL file. I've done sort of a commentary on that in the past. So those of you who've seen my previous videos have known that I've not been too fond of this change, but anyway, it is what it is. It's been made, and we are in the world of AIDL. Now, to the benefit, I should actually correct one of the things I said a few years ago, because one of the things I said is I was concerned about the sort of change of major numbers since the this documentation of the AIDL hardware support was saying, well, if we need to re-architecture the entire API, we're going to call this sort of Bluetooth 2 instead of like Bluetooth. And to their credit, there aren't any of those 2s or 3s in the actual tree right now in the hardware interfaces directory. So presumably this works in some way, shape, or form. Or maybe I'm missing something. But anyhow, the major and minor number were the things that I really liked about HAIDL. But anyway, so right now we're using AIDL, and we are fully into this world now. The HAIDL stuff is gone. In the AIDL world, you would use a remote process for a HAL implementation and then rely on the VNDK libraries to provide the actual support over the lifetime of the implementation. And this is where the innocuous announcement inside the release notes saying that the VNDK is deprecated sort of hit reality when I started digging into Android 15. I was like, wait, what are you doing here? You're doing more than just deprecating VNDK. So what is it that we are actually seeing in 15 that changed from 14? At least that you can see in Cuttlefish, all right? So not all devices have caught up to this schema, but it seems to me, looking at what's in there, that it's pervasive enough that they've actually sort of, they're really going into that direction no matter what device you have at hand. They're definitely going to the direction of whatever they're doing with Cuttlefish. All right, so let's actually take a look first at the Hardware Service Manager. So the Hardware Service Manager was essentially one of the pieces that were required to run hardware support inside AOSP. This was introduced in version 8, and you could see that running by just doing a process list and looking for it around. And here you can see it, but in 15 it's just a lost cause. And I sort of just took a screen grab, but maybe it's a bit small here. So anyway, it's not running, and I try to start running it. It then complains that HW Service Manager is not supported for on this device, as you can sort of see here, is not supported. And I sort of did more than just that. I tried to actually get it supported on the device, and that didn't really work out too well. And after a while, I said, okay, I'm giving up on this. It's not actually working. Let's forget about HW Service Manager. It has gone, it has gone south. It's been sort of, removed from any usefulness in future AOSPs, and as far as I can see. So in 14, you could still do an LS-HAL, LS-HAL, even though, the use of AIDL had been introduced in 11. HALs were still being used, and you can use LS-HAL to see them nowadays. If you grab in Android 15, which is what I'm running right here. So if I do something like LS-HAL, it's a bit underwhelming. Ignore the sort of a thing here. That's me hacking my AOSP. Ultimately, there should have been no output there. There's nothing actually there in terms of output from LS-HAL. It's just totally gone, right? Now, one thing that's even more interesting, that's where I start scratching my head a bit more, is when you try to look for the HALs, the HAL implementations, which were under vendor bin HW in 14, right? You look for them in 15 and hey, that directory's not there no more. Okay, where'd you put my HALs? I want to know where my HALs went. You took away my HALs, they went somewhere, all right? In 14, there were some hardware apexes that were implemented. You could find them by going into /apex, and you could just look up anything that was called com Android hardware or com Google CF, being cuttlefish, right? And you can see there's a couple of things, maybe, I don't know, just a visual here, maybe a dozen of them, all right? Do the same thing in 15 though, and that's several dozen entries. Like, okay, wait, what's going on here? I mean, there's something that happened along the way in 15 that clearly wasn't being done in 14. And as you can see essentially here, what we're really seeing is all the hardware's now an Apex. All the hardware support's now done as an actual Apex, no longer as vendor bin whatever or whatever is you put wherever you put it in before. All right. And here's another interesting thing. If you sort of start looking deeper into those apexes, you can see that in previous versions, 14 at least, and by the way, they had started doing some hardware apex stuff. I can't just recall pin it down to which version exactly, but it started somewhere, right? But even in 14, as you can see, like right before 15, it wasn't that big. It wasn't that much, at least not in the case of cuttlefish. And I looked around the other devices, the sort of Pixel devices under device Google blah, and most of them were still not doing that. Jimmy, give me 1 second. I have to do something. I'll be right back. All right, problem fixed. The other thing is, if you start looking deeper into those hardware apexes, you'll see that in 14, the actual libraries included in them were not too many. I mean, just the bare essentials there. Maybe 1 or 2 at most for each of these apexes. You go to Android 15 and it's like, wait, what? Now you're actually including a whole bunch of things, including, suspiciously, for my eyes, as I come into 15, not knowing what the heck they're doing. They have something like libc++, libcutils, libbase, and I'm like, why are you including this stuff? Isn't that given to you by the VNDK? Oh, that's right, you removed VNDK, so what are you doing here? So that's essentially the deprecation of VNDK is solved by putting the libraries in the apexes. Ta-da! Problem solved. Why would you bother? I mean, so essentially here, the solution, or what's not written on the release notes of Android 15, is that the deprecation of VNDK has also meant that now when we're apexing those HALs, we're shoving into them all the libraries they ever need. And that sort of has a few ramifications probably, if you've done any maintainership of those apexes over a long period of time, something to sort of keep in the back of your mind as you move forward. Okay, and the weird thing, and that's sort of like really kind of threw me off, and I sort of went down the rabbit hole on this one for a couple of days. I mean, sort of not continuously, but it's like I start looking down. I was like, I can't find this. Okay, let me move on. And I come back to another day and try to look for it. I'm not sure I can find this. And after a couple of days, I think I nailed it down. But anyway, if you take a look at the actual sort of default power HAL BP file. So by the way, this is the BP file for building the Apex that has the power HAL. You can see that in the actual description of the Apex, there is no reference to the libraries in question. It doesn't tell us here anything that resembles, or sorry, wrong window, that should resemble a native shell libs, which would be the statement saying these are the libraries, unless I'm missing something else. But usually that's the statement you would put in Apex saying I need those libraries in my Apex, and we're not having that in this BP file. So what gives? All right, I had to search for this one a bit more. So anyhow, if I continue with the same sort of diagrams that I had before, this is what we end up with today. All right, so we end up in a situation where the AIDLs, by the way, also most of the implementations these days may not need to actually talk to C++. They can go from Java straight to AIDL, which is sort of interesting because on one side you may have Java code, the other side C++ code, but then you have the actual documentation on source.android.com that tells you the correspondence on the two things, so we should be okay. But anyhow, keep in mind that there may be no interfacing C++ code as they used to be a long time ago to talk to the hardware definitions. But anyway, from the AIDL definitions going into the actual other side, the vendor provides now HAL. It seems to Google wants us to provide essentially, by the way, because not all Pixel devices do this, but anyway, they should provide vendor HAL apexes where you have the HAL implementation and the libraries sort of included inside, and I put the dashed sort of line around the box with HW Service Manager because it may not actually be running on your system at all. All right. Let's talk a bit about Apex for those of you not familiar with that, because in order to understand what we're doing here, you need to understand what apexes are and how they actually work. So apexes were introduced, if I recall correctly, in Android 10, the idea being to sort of ease the way by which some of the major parts of the system partition get updated. So they call this modularized system components. So stuff from the system partition was removed and then put into an Apex file. And what is an Apex file? It's essentially a zip file with an actual file system image inside of it. So this is no longer sort of the traditional sort of content of an APK, because that actually is the format that we use. An APK would actually have DEX files inside. We don't have DEX files here. We still have an Android manifest, but essentially it's a file system image, and this file system image is DM Verity signed to ensure that it came from the proper party. And so, the checks are made and so on and so forth. All right. In order to understand what they're doing with the HALs libraries and apexes, you have to understand what a transitive dependency is, and I assume you might or may not know what this is, but anyway, a transitive dependency means that I'm including B and B includes C, so I do depend on C even though I don't know about C. And what we see now in the documentation of the Apex on source.android.com is that it tells you that they are going to fetch those dependencies automatically for you and include them inside your Apex, which is interesting because presumably they would have done that before. But if you actually track down the actual sort of commits, you're going to see that they actually had an exception for things that depended on the VNDK, and they removed the exception, is essentially what I found. So library should be included. This is actually the verbiage I was looking for. I was like, there's got to be a commit somewhere that tells us that we are including those libraries. Please, 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 where are you? And I eventually found it. All right. So there is a commit that says essentially that we are now including, the libraries inside the Apex for use by them. If you go to the code of the apex.go, which is the file that is used to build the actual apexes. They actually had essentially an exception here saying, hey, if it's a VNDK transitive dependency, well, we're not going to include it because we're not going to duplicate it. We're going to put it outside, and that code is actually gone. Here's the actual sort of, some of the commit that actually removes some of the stuff. And if you do something like this here on the proper directory, which is build sung, right around, actually I think I got it right there. So yeah, this actually check is actually being removed here. So we're no longer actually doing an exception for that. It's just totally gone. So that essentially is the way they solve the problem. Is now we don't check transitive dependencies exceptions for VNDKs, for HALs or anything depending on VNDK. We're just including the libraries regardless. All right. So this is a diagram that I've used in the past in some presentations, and I've seen it actually float around in some documentation that doesn't actually attribute back where it came from, but it doesn't matter. Jokes aside, this essentially is how things were done before Treble, how things were done at the introduction of Treble, and if we take a look at it as today. So we have essentially binderized HALs over AIDL. And just to walk you through, if you've never seen this diagram before, up over here is the actual applications talking to my system service, which is right down there. If you kind of imagine a line that's over here, most of the stuff up there hasn't really changed in any of those versions. All right, applications have developer API that they use to talk to the framework libraries. Over the framework libraries, you use AIDL to talk to the system service, which may or may not use these days JNI to talk to some C++ code, because that actually is often these days I see it happening like right there, straight from the Java to the AIDL. And then the AIDL code, interface allows us to talk to the implementation, which these days is apexed, and then going down to the hardware on the other side. And I'll sort of try to give you a walkthrough of this in a short bit. All right, so that's sort of more or less how things evolved. Notice here that we had headers in the beginning. All right, and this HAL module was an SO file. Afterwards, we had HALs definitions. And you could still have SO files, but mostly you wanted a remote process, and these days you have AIDL definitions and a remote process that is actually housed inside an actual Apex. All right. So let me give you a bit of a walkthrough here of this stuff, show you where things lie and how things have sort of more or less evolved over time. So I'm going to grab essentially files from cs.android.com, and we're going to do a bit of a walkthrough here, see how things have evolved over time. What I'm going to grab really is, how should I do that? Yeah, let me grab sort of a version here of an old style, 8.x HAL, and then show you how things are done today with the AIDL implementations of those things. So let's go grab something like 8.x, whatever that is. So let's go grab here, and I'll just grab a notepad here. I'll put those URLs in there, maybe paste them back into these slides for those of you who want to do the same follow or walk through afterwards. So if you go to framework space, you go to, let's go to services, let's go to core, Java, nope, wrong directory, com, Android server, and let's go grab the same thing I had grabbed a few years ago. So if you've seen the video before, the other video I'm talking about the HALs, I did use the Light System Service as a demonstration. So let's open the Light System Service here. Let me put that, actually I am now in Android 15, that's not what I wanted. So let's just change that, Android 8 dot blah. 81, good enough for me. So this is the Light System Service from 8, okay? Just to focus where we are here, I'm talking about something that does this, all right? An old style, nowadays old style, HAL implementation of a HAL. So if you take a look at how this works in the constructor of this class, which is somewhere around here, all right? We essentially have nothing that is happening. Previously in the HAL implementation using SO files, it would actually do a init native, and then it would sort of do an HWGit module and load some SO file. Anyway, I'm not showing you that. What you will see is that if you take a look at the Java code, the GenI code that corresponds to the system service, because the only way going down here is the set light native. If you go down to that, under native, and you grab com Android server light service, this guy here, and let me put that in there as well. So in the actual set light native, which is over here, what it does is a call to this thing called associate. And if you go take a look at the associate in question, which is also in this same file, it's really doing a HAL lookup. That's really what this get service is actually doing. So this is an old style way of doing it, all right? And once you sort of carry over and walk down that, what you're really seeing is just this, sorry, this HAL lookup that might, by the way, from the system service perspective, might give us a remote process. We don't really need to see that. But anyway, goes down to some sort of implementation and then takes us down to the actual device driver. How does this work in a present day world of, you know, AIDL use of these interfaces? So going to 15, which is over here, let me go to framework space, and actually let me just choose the one that I am certain of having played with. So not that the changes are really should be that big, at least for that in that section of the sources, but just making sure. Framework space services, let's go to core, Java, com, Android server. Let's go grab the light system service, and let's go grab this guy here. So in this case, in the constructor or constructors lights service, this guy here. So what you're gonna see here is really we are actually sort of now using what they call here this VNDK HAL cache to retrieve some sort of implementation for the actual sort of system service. And if you, sorry, HAL implementation. If I go down further down there in the VNDK implementation in question, which is right there, what we're doing is a service manager, wait for declared service, iLight default. We are looking up the iLight implementation in AIDL. All right, straight from the Java side. We're not sort of bothering going to some C++ code to do the lookup. We're doing it right from here, looking up an implementation of the iLight HAL, if you will. All right, and this pattern, or something similar to this, you're going to find in some other things as well. It's looking for default. Where's that come from? Well, if you go here on the command line, and you do a service list. Let's go grab for, I'm not sure if they have it in here. They do, actually here it is. So it shows up here under service list. By the way, service list, for those of you not familiar with it, or I presume you do know what this is, lists me as system services that are available in the system. And nowadays, since everything uses AIDL, and we don't have LSHAL anymore, it's very confusing because the HALs are in the same location as the system services. When you list them, you can sort of grep them around by doing grep, you know, android.hardware, a kind of approximate way of finding them. And you can see there's a whole bunch of things that are now AIDL'd. So all these are all essentially the AIDL implementations of the HALs. So essentially the default implementation is being looked for, and once we retrieve that, we have a conduit to talk to the actual process. And just going back to my diagram here, what I was doing in this case is a lookup in Java for an AIDL implementation of this thing right there, all right? So I'm looking for the implementation of the HAL, and in the case of Android 15, that's going to be found inside an Apex, all right? So if you want to go take a look at where that is, you would have to go under Apex, and you would have something like, you know, something like com Google CF Lite, all right? And that's actually the implementation of the lights for the cuttlefish. And under bin here, HW, I now have the, you know, light implementation for this. And of course, as I just mentioned, if you take a look at the libs that go with this, lib64, oh, come on, or they don't have anything for light. Yeah, so no libraries in this case for cuttlefish. Boohoo. But by the way, if you just do something like ll.com.android.hardware */lib64, yeah, you're going to see that a whole bunch of these have the libs included inside of them, exactly as I just mentioned, with the the deprecation of the VNDK, meaning we just shoving the libraries right in there. Now, if you want to take a look at how this is implemented on the other side, you've got two choices. You can go take a look at implementations in Cuttlefish, or you can take a look at default implementations under the interfaces. So I would have followed the lights implementation to show you how that is actually done. Unfortunately, now both in the Cuttlefish and in the actual well, not unfortunately, but anyway, both under hardware interfaces, which is where I'm going. If you go to hardware interfaces and you go for light here, the AIDL implementation, you go take a look at the default implementation. It is implemented in Rust. So it's not that I have anything against Rust, but since maybe not everybody is literate in Rust, I'm not going to follow this example to show you what's going around. If you take a look at IR though, you can look at the Android default, and this is still a C++ implementation, and this is simple enough to actually be followed. So this is, the actual implementation of the IR, and if you want to see how they generate this stuff, you're going to have to go look at the actual files that are generated by the build of the AIDL file in the app directory. All right. So some of the like the C++ prototypes of the functions, especially this here, this class thing, the class definition of what has to be implemented in C++. This is more easily sort of stolen from the files generated in the app directory. They shouldn't be too hard to find if you know what you're looking for. All right, what is interesting here is to look at the actual Android BP here, because we are sort of compiling a binary, right? This is, of course, required. It's a remote process, but we're also generating an Apex, all right? And so we're telling it here is the binaries that you want to include here. Here are the actual pre-built files that you want to include in there. And there's a bit of, here's the manifest of the Apex, all right? And here are the file contexts of the security context. So if you take a look at the JSON file here, this is the JSON file describing the Apex manifest. And then you've got here the Apex file contexts, which is the actual access rights to the SE Linux access rights for the files that are found in there. So you can find several. Actually, so if you follow the commit dates of when they deprecate VNDK and stuff, you can see there's a whole bunch of commits, and you follow the right people. You can see a whole bunch of commits where essentially they're sort of changing each of those default implementations from being going to vendor bin HW to actually generating an Apex. So they're sort of like doing this whole thing, this whole re-architecture of the whole thing as Apexes, as they're sort of removing support for the VNDK along the way. And if you were to go to actually Cuttlefish, so device Google Cuttlefish, and you go take a look at guest HALs over here. And by the way, I've not been following up to what I was saying, which is to provide you with URLs. So let me just put that back in here. And I forgot the other one, which is... Sorry, just doing my homework here. This is the one from 15, Java. Yeah, so I'm cheating a bit, going to the IR instead of lights, but that's just because of what I just mentioned. Okay, so that, and if you go to the HALs, yeah, this is the other one I want to give you. These are the HALs from Cuttlefish, and those two have been apexed, by the way. So if you go take a look at, say, lights, which also is implemented in Rust here, has been apexed. And if you go take a look at, I don't think this one has anything, by the way. Yeah, you can take a look at some of the ones here I can't remember which one was, you know, health, which is C++ code. And you can take a look at the apex of that. And again, it sort of will generate, the AOSP, sorry, which is actually implementing an apex file here, as you can see. So that's just been the pattern that I've seen across the directories on our hardware interfaces and the entries in Cuttlefish is for all those HALs that were implemented there, either by default in the hardware interfaces or for Cuttlefish, they've all been apexed. So clearly the trend is in that direction to just make HALs as apex files instead of just binaries somewhere in the file system. So anyway, I kind of showed you how to implement those HALs in AIDL and apexing of HALs, which is, you know, brings us towards the end here regarding this specific topic. And so where does this take us next? So if you have something that's still HAL built, 4.15 won't provide you with an exit for that. I mean, you can still try to solve that problem that I wasn't able to solve and I gave up on. I rage quit, as my kids would say, of getting HW Service Manager to run. But it's a lost cause. Even if you were able to get it to work here, it's gone in the future. Yeah, so the HALs are now fully self-contained in apexes files, which is interesting. I'm not sure I kind of fully grasp all the ramifications of it, but if nothing else, it makes them bigger. But hey, as I tell people, if you've chosen Android, you've already forfeited any right to complain about size. So who cares, right? It's bigger, but it's not a problem, right? So the apexes, of course, have all the libraries inside of them. So just be mindful of the AOSPs that you actually used to generate them, because if you do actually want to update that apex at some point in the future, it will probably need those libraries that you got from that AOSP, since the VNDK is of no sort of, the VNDK is no longer something you can use to help you out. All right. Yeah, that's pretty much it. So that's, in short, just be aware that now the HALs are all contained in apex files, and they are all presumed to be AIDL. And should have been, for a while. So yeah, that's it on my end. I'll sort of share those slides a bit later when I've had the chance to do that. In the meantime, if you do have any questions, please feel free to post those on the chat. I'm happy to sort of pick those up as they come. I haven't seen any just yet, but in case you have any, I'll stick around for a minute or two here and see what comes of it. All right. Sometimes the stream is a bit delayed, so this is why I usually wait, because I don't know when you're actually hearing my call to questions. Yep, you're welcome. Glad you liked it. All right, folks. It doesn't seem that we've got any sort of questions. So then I won't keep you any longer than that. You've got most of the stuff in the playback if you want. And I will, as I said, post the slides and the links to the some of the files that I sort of went through. I went through it, quickly, really. I mean, just take the time to review the video and the links that I give you if you want to sort of walk through the code more carefully if you wish. But the essential sort of takeaway again is the inclusion of libraries in the in Apex files for HALs, and if you're like the more curious type like myself, and you want to understand how the heck did they get those libraries in there, and because they're not listed, well, that's because they actually changed how the build system includes them. All right, take care, folks. See you soon.